2013 prelims question from general geography, and this question was related to the movement of the Earth. So the question read, variations in the length of daytime and night time from season to season are due to the Earth's rotation on its axis, Earth's revolution in an elliptical manner, latitudinal position of the place, and revolution of Earth on a tilted axis. So let's analyze this question. The first option it says is rotation of Earth. Now rotation of Earth, as Earth rotates on its own axis, the first thing what happens is Earth presents different faces to the Sun. And so let's suppose this is the Sun, or I am over here standing as Earth and this is Sun in front of me. So if I'm rotating like this, the first thing that is happening is I'm facing the Sun, or sunlight is falling on me. So for this, okay, I have daytime. But as I rotate over here and as I face this side, okay, now on my face the light is not falling, and so I am in the darker side, and that's where night occurs. After that, I again come over here and I have the sunlight falling on me. So I have day. So day, night, and the cycle repeats. This is diurnal cycle of day and night. So first impact is the occurrence of day and night. And with this day and night, what we see is, if I take the Earth over here, the sun rays falling on the Earth. Over here, what I see is a maximum the sun rays can touch this and this part. And so the sun rays are effectively falling only on this side. So this represents the day, and the opposite side, which would be the darker side, this is going to represent the night. And this circle, which has been created by the sun rays falling, okay, this circle is called a circle of illumination. So this is the first effect produced by the rotation. Second effect produced by the rotation is with the concept of time. So how do we follow time? It is based on 12 noon concept. 12 noon, when any place faces the sun directly. So again, if you see, I'm facing the camera directly. So in this case, for me, this is sun, and so for me it is 12 noon. But as the rotation is going to happen, I'll move here, and so now I'm facing over here, not here. So if during this movement, okay, 1 hour has elapsed, so for me 12 noon, and now it is 1 p.m. But at the same time, when I was facing over here, a place over here, this was facing in this direction. As I move, now this place faces the sun. So this place now will be having 12 p.m. So when this place is having 1 p.m., this place is having 12 p.m. So as the Earth rotates, okay, different longitudes face sun directly at different time. And so all these places follow different time. And very obviously, whole of the longitude faces the sun at the same moment. So all the places on the same longitude have same time. So this is where different time zones come into picture. So second effect, that is the occurrence of time zones. Apart from that, as the Earth rotates, any body moving on the Earth, it suffers an apparent deflection. This deflection is due to the rotation itself. And this deflection effect is called as Coriolis effect. So with this Coriolis effect, what I see is a law called as Ferrell's law governing the movement under Coriolis effect. And what is this law? It says that northern hemisphere mein, okay, the movement is towards right, which means if a body is moving in this direction, it would be deflected towards the right, or it is moving in this direction, so it would be deflected in this direction. And likewise in southern hemisphere, leftward deflection, which would mean a body moving in this direction would be deflected along this side, or a body moving in this direction would be deflected along this side. This is Ferrell's law governing the Coriolis deflections. The Coriolis effect is the third effect, and the fourth effect is the occurrence of the tides. tides occurring in the oceans. So the occurrence of tide is due to the gravitational pull of sun, gravitational pull of moon, as well as the rotation of earth, which provides for requisite centrifugal force. So these are straightforward 4 effects of rotation. Okay, and here I can very clearly see it has nothing to do with seasonality. So that's the first thing. So over here, Earth's rotation on its own axis. Okay, this definitely is not the answer. Second is Earth's revolution around the sun in an elliptical manner. So in this case, what I see is the Earth moving around the sun in an elliptical orbit with sun at one of its focus. Along this orbit, the Earth is going to reach 2 extreme positions. Okay, the distance would be constantly changing because it is an elliptical orbit. And this point, this would be when the Earth would be nearest to the sun. And this point when the Earth would be farthest from the sun. These positions are called as perihelion and aphelion respectively. So with perihelion and aphelion, will the seasons occur? On the face value, it may appear in this part, okay, let's say, okay, as the Earth is nearer to the sun, okay, it should be summers, let's say, or in this part as the Earth is away from the sun, it should be winters. But I have to remember this point that if this was the cause of seasonality, then in this zone, when the Earth is nearer to the sun, whole of the Earth is nearer to the sun, which means whole of the Earth at the same time should be experiencing summers. But it doesn't occur like that. Rather, when it is summers in northern hemisphere, it is winters in southern hemisphere, and vice versa. So definitely this has nothing to do with seasonality again. What at the maximum it is going to do is, okay, when the Earth is going to reach in this zone or reaching at perihelion, the temperatures would be slightly raised. And here the temperature would slightly drop. But this slight increase or decrease in the temperature is not a seasonality. Okay, it is just a slight moderation or the seasonal becoming extremes. Okay, like you have winters. During winter season itself, there would be some days when the temperature would be slightly 1-2 degree higher, or some days when it would be extreme cold, 1 or 2 degree lower. So within the season, intra-season fluctuations that would happen due to perihelion and aphelion, but definitely not the occurrence of seasons and the seasonal variations overall with respect to day and night. And so over here again, if I see second option, Earth's revolution around the sun in an elliptical manner, this also cannot be the answer. Third, that is latitudinal position of the place. Now, latitudinal position of the place, okay, this straightforward cannot be the answer, because latitudinal changes or not, okay, seasons are according to hemisphere. Whole of the northern hemisphere summers, whole of the southern hemisphere winters. So latitudinal position is not going to impact the variation in the length of daytime and night. Yes, of course, one thing that is going to happen with respect to the latitudinal position. So when I see latitudinal position, in this case, what will happen is the differences in terms of, okay, length of day and night definitely is going to be impacted. Take for example, at the equator, if you take, at the equator, day and night are equal. As I move away, and when I reach, let's say 90 degrees north or south, okay, what happens over here is for 6 months you have daylight, for 6 months you have night, complete darkness, which means during summers, what is the length of daytime? 24 hours. During the winters, the daytime is how much? 0 hours. 24 hours is night. So here the seasonal, the differences if I see with respect to length of day and night, okay, that definitely is impacted, but not seasonal variation as such. Latitude wise within the same season itself, I'll have more and more difference in the length of day and night. So if, say for example, if I am saying summers, northern hemisphere, summers, northern hemisphere summers में at equator, okay, length of day minus length of night, how much it would be? 0. Length of day and night is equal. Okay, whereas if you reach, let's say 30 degrees north latitude, 30 degrees north latitude में day minus night. So day minus night, it would be something like 30 degree latitudes on 30 degree latitudes. If the day is of let's say 14 hours, night is 10 hours only. Arbitrarily we are taking the values. So 14, 10, I'll get 4 hours. If you further reach, let's say 60 degrees north, this difference would be more visible. Okay, wherein the conditions can be, okay, 18 hours of day minus 6 hours of night, which means 12 hours. And when you reach 90 degrees north, the day minus night, day is 24 hours, night is 0, which means 24 hours difference you are getting. So difference in the day and night, difference between day and night length, that definitely is impacted by latitudes, but not variation in the length of day and night. So that is something where again I have over here the latitudinal position. And fourth is the revolution of Earth on a tilted axis. Now revolution of Earth on a tilted axis, this is something where Earth tilted, and this is one scenario, okay, where sun rays are falling like this, and I have over here, okay, the latitudes. So if I see these latitudes over here, in this case, the sun rays are falling on this part. So as the sun rays are falling in this section, okay, this is where you can see this becomes our circle of illumination. And so if you see this particular latitude, okay, this latitude, I can see this much part is on the day side and this much part is on the night side, which means at this particular position, okay, we have more of the length of day and less of the length of night. Now as the Earth rotates, okay, in the winters of northern hemisphere, the face that it is going to present to the sun now is going to look like this. And over here the sun rays are falling like this. And again we are going to draw the latitudes. So in this case, now what I see is the circle of illumination over here now. And so the latitude I am checking is this latitude. So you can see this much is night and only this much is day. So obviously for this place now, the day has become shorter, night has become longer. And that is what is the idea of variation in length of daytime and nighttime seasonally. In summers, I can see more of the day, less of the night. In winters, I can see more of the night and less of the day. This is precisely when the Earth revolves around the sun on its tilted axis. Okay, that's where this effect is produced. So that is where, okay, for this particular question, okay, the variation in the length of daytime and nighttime from season to season are due to revolution of the Earth on a tilted axis. So this is the correct answer. Now based on this, Okay, I have created few questions for your practice. The first one pretty much based on the same question only. I have just changed the initial statement. So first related question, the occurrence of aphelion and perihelion position of the earth are due to, and this we have already discussed just now. The earth's rotation on its axis, earth's revolution, same options are there. I have just changed the statement of the question. Okay, as it is always applicable, answers I am not going to reveal. Answers you guys are going to find out by yourself because this is for practice, and you can type in the comment box and discuss the answers also. So this is the first question for us. Second practice question, the latitudinal position of a place determines difference in length of day and night at that place, length of respective seasons at that place, time zone of that place. So this is the second question for practice, and we have third question over here. Which of the following effects are produced due to revolution of earth on a tilted axis? And the options is variation in length of day and night, cycle of seasons, midnight sun. So these are the three questions for our practice based on the question that came in 2013 prelims.